3/4 stick and an inverted hover at 1/4 stick. Again, for the upright climb out, we need a certain amount of positive tail rotor pitch, and then down to 0 degrees main rotor pitch at half stick, we need to take out a certain amount of tail rotor pitch. That's exactly what we have here. We're just taking this and moving it right here. Now, when we bring in main rotor pitch for an inverted hover, we need to bring the tail rotor compensation back in, and then for an inverted climb out, we need a little bit more tail rotor pitch. In the DX7 stunt mode, it bases the changeover point at half stick, which is good. So you can go ahead and run positive tail rotor pitch and get this point correct, even though it's going to be off a little here. You can run and get this point correct, even though it's going to be off a little bit here. But the real problem is there's no way to move this center point down so the tail rotor pitch is right for 0 degrees main rotor pitch. About the only way to get this type of tail rotor curve is to use a program mix that's curvable. The DX7 doesn't have a curvable program mix, and you need an upper end radio such as the 9303 to get a curvable mix. Now that we've looked at the philosophy, all that we have to do, again, notice when the stick is down, it flashes down, and then up. When the stick is up, it flashes up. Again, we just need to make sure that both of these values are 0. And the same thing applies for the DX7. Here you can see that we have a separate up and down mix and a separate up and down mix for stunt. Again, we want all of these values at 0. As we get into program mix, I want to take a few minutes and give you a solid understanding of what program mix can do for us. Program mix is one of the critical keys to making an electric helicopter fly perfectly. And the reason is, we can set the rotor RPM for a moderate upright hover or inverted hover, and then when we put in cyclic deflection for aerobatics, the helicopter will hold the rotor RPM. And a roll out. And a roll in. 1, 2, 3. A lot of guys today are flying electric helicopters with absolutely no program mix, and so they're running 100% throttle across the top of the board. If they don't run 100% throttle, when they do aerobatics, the rotor RPM sucks down. As a matter of fact, I flew my first 2 loops and first 2 rolls in my T-Rex without program mix, just to see what it would do. The helicopter didn't like it. So, program mix is critical. Here are some examples. Let's take, for instance, aileron as the master and throttle as the slave. This would be program mix number 1. Here's center stick. With full right cyclic deflection and with full left cyclic deflection, we want the throttle to increase. We'll be able to see this on the servo monitor. With 25% program mix set and we give full stick deflection, that's adding about 12% throttle. And this is why we're setting 88% throttle at the top and the bottom of the aerobatic flight modes, so that we can go to full power, and then when we put full cyclic on top of that, the throttle will be driven from 88 to 100%. Now, one of the real neat things about program mix and the electric helicopter is that the electric helicopter doesn't care if it runs 2,000 or 3,000 RPM fast. So this is what we can do. We can set up a moderate inverted rotor RPM for inverted and upright. Then we can run a little bit more program mix, say 30%, maybe even 35%. I'm going to use 30% for the example. If you set 30% of program mix, then that gives you 14% additional throttle. That means you'd set the throttle at 86 for the aerobatic throttle curves. So that, what'll happen then is that the helicopter will hover in a relaxed fashion, upright or inverted, and then when you put in cyclic pitch to do aerobatic maneuvers, the rotor RPM will increase and tighten up. So the helicopter will be nice and tight. It'll have a real nice tight feel during aerobatics, but yet when you're in a stable inverted or upright hover, the rotor RPM will be nice and relaxed. It's really cool. Give it a try. After we've set up aileron to throttle mix, we can do the same thing. Everything is exactly the same for elevator to throttle mix. As we give up elevator, we want more throttle. Down elevator, more throttle. And using program mix will just give absolutely perfect aerobatic flight. For program mix A11, the 1 and the 1 are the channels. So this is set up to mix throttle to throttle. As I talked about on the board, we want to use this program mix to mix aileron to throttle, or in the case of an electric helicopter, aileron to the motor, but it's the same thing, it's the throttle channel. Here we're looking at the percentage of program mix. Let me go down on the left button. There's the offset. The offset just determines if you want the program mix off center. We do not. Okay, and so here's the channel. If you go up on the right switch, that will set the left side channel or the master channel. And if you go down on the right switch, that will set the slave channel. So we said we wanted aileron, which is 2, mixed to throttle or motor, which is number 1. So there's 2 and there's number 1, so we have aileron to throttle mix. Next, we have a selection of whether we want the switch on all the time or whether we want it set up for flight mode 1, and that would be with the switch in the forward position, flight mode 0, which is the switch in the back position, or the hold switch for auto rotations. We don't want anything for auto rotations or on the hold switch, so therefore we want the program mix on all the time. Because if we're in the normal flight mode and we put in a small amount of mix, we'll get a small amount of throttle input. If we put in a large amount of cyclic input in flight mode 1 or 2, then we'll get a large amount of throttle input to the throttle during aerobatics. So we want the switch on all the time. With the switch selection set, now we can go ahead and go down on the left button and program those variables. Now, what I'm going to do is just swap servos here. I'm going to plug the elevator servo into the throttle channel and relabel that, and I'll be right back. We'll play with the values. Now I've got the throttle servo hooked up. The first thing that we need to do is see which way the throttle goes when I add collective pitch. The throttle goes down, so that's more collective pitch. Now I've got 0% of program mix in here, and you can see my 2 roll servos deflecting with the aileron or the right-left cyclic input. So what I want to do is when I go to the right, I want to see the throttle move down, and when I go to the left, I want to see the throttle move down. And again, anytime you load up the cyclic, whether it's right cyclic or left cyclic, we need additional throttle to compensate for the added drag that comes with added lift. So let's just go to, and what we're going to do is we're going to set these at 25. I've just gone arbitrarily to minus 25. And which way is minus 25? Okay, minus 25 goes to the left, and the servo goes the wrong way. So I can move the left one down, the right one up. That zeroes that. And now what I want to do is go to plus 25. So now, when I move the stick to the left, the throttle servo adds throttle. That's great. Now, if I hold the stick over to the other side, I get the other side of the program mix. Again, I'm just going to guess, and actually with the stick deflected, I can actually see my servo move, so I know that minus is the right way. So I can bring this back to minus 25, and now with a full right cyclic deflection, I have added throttle, and with a full left cyclic deflection, I have added throttle. The program mix is set up perfectly. Here's the first program mix for the DX7. To activate it, we can just hit the rocker switch on the right side. We want to mix aileron to throttle. So we'll go ahead and cycle through the options until we get aileron, which is right there. Throttle is automatically set for the slave channel. Now we'll use the select button. And again, if we wanted to select something different, we use the select button to go over to throttle. Now we'll go to the rate, and what I want to do is run 25% mix, and then by moving the stick off to the other side, it'll highlight the other mix value. So I'll go 25 and 25. Now to see which direction I'm going, I either have to plug in a throttle servo, or I can just go ahead and I can go to the aileron versus throttle monitor screen. So when I give aileron, there you can see the deflection. Well, first I need to see which way throttle goes. Okay, at the very top you can see when I increase stick, the throttle goes to the right or up. So when I give aileron, I want the throttle to go up. There it goes down for right, and for left it goes the proper way. So for right aileron, I need to go back and reverse that to minus 25. Okay, now let's go back to the monitor screen, and now when I give right aileron, the throttle increases. When I give left aileron, the throttle increases. So that verifies that the aileron to throttle program mix is working properly. Now I can drop back down. I want the switch on all the time in all the flight modes, and I want it to work right off of center. I don't want any offset. So that's program mix in the DX7. For program mix number 2, I want to activate that. And this time, I want to set up elevator to throttle. I want to do the same thing. I want to go to rate, and this time I'll use the elevator switch to move the arrow from one to the other. Again, let's set 25. And 25. There we go. We'll hop on over to the monitor screen. When I increase elevator, okay, when I give up, the throttle goes the wrong way. When I give down, the throttle goes the right way. So what I want to do is with up elevator, I'll drop back into there, and I'll set that to minus 25%. And then verify that. Back in the monitor screen, up elevator, the throttle increases. Down elevator, the throttle increases. And everything is good with program mix number 2. Another easy way to check cyclic to throttle mix is to bump up the trim so that the motor almost starts to go. And let's see. Okay, there I'm just under half trim. Now right there I'm at about quarter trim, and when I give a cyclic input, that will add more throttle so the rotor RPM will increase. So for instance, here's right cyclic. Okay, that increases. Here's left cyclic. That increases. Aft cyclic. And forward cyclic. And so that's a really cool way to verify that your program mix is working the right way. For program mix number 3, I want to set that up to mix rudder to throttle so that when we do pirouettes, the rotor RPM stays constant. Now this is a very small amount, normally about 3 to 5%. And so there's rudder to throttle. And because the amounts are small, what I want to do is set a large number so I can see which way they're going. So I'm just going to kick this up, just to 40% right now. And when I kick over the rudder, it'll go up to 40%. Okay, now let's go to the monitor screen and see what we have. When I give left nose, that will take off the load, and so generally the RPM will have a tendency to increase just slightly. So when I yaw to the left, I'm looking for the throttle to come out. And the throttle goes in, so that's backwards. So let me just hop back to that. And we'll go left, and we'll go minus 40. All right, let's go back to the monitor screen. Now, when I go left tail rotor, now the throttle comes out. When I go with right tail rotor or right rudder, I want to see the throttle increase a little bit. Again, it comes out, it's going the wrong way. So I need to go back, and I want to change the plus 40 to minus 40. So there's minus 40. Back to the monitor screen with right rudder. Now the throttle comes in, and with left rudder, the throttle comes out. So everything's verified that it's working properly. So now I'll go back to the screen, and I'll simply reduce the minus 40 value down to minus 5. And then on the other side, I'll take the minus 40 and I'll set that to minus 5 as well. So now I'll have well-nigh perfect rudder to throttle mixing. Before we get into CCPM, let's go ahead and break down how eCCPM works. Again, in a conventional MCCPM system, which is mechanical CCPM, the collective and the cyclic throws are completely different. In E, or electronic CCPM, all of the cyclic and collective throws are mixed into 3 servos. Here's how it works. Here's a servo wheel, and let's say that the servo arm is perfectly centered at half stick, which will give 0 degrees main rotor pitch. Now, if we use the standard of 60% collective pitch, that will deflect the servo arm this much. Now, if we add a cyclic input on top of the collective, that will deflect the servo arm even more. Now, with the standard values of 60% and 60%, we don't have to worry about hitting the limits. The servo, or these percentages, are set up so that the servo will accept that amount of throw. The reason that we want to keep sub-trim minimized is so that we don't run out of the servo throw with collective and cyclic and then sub-trim added on top of it. In the top example, let's say that the servo arm is not centered, and here's a 45-degree line on either side just for example. Let's say I need 25 points of sub-trim to center that servo arm. When I do that, this endpoint does not change, and there's less throw from 0 degrees pitch up to the limits of this servo throw, and there is more, or I have more degrees down on this end, but again, I'm checking for what is the limiting factor. So, if I have a certain amount of collective, a certain amount of cyclic, and a certain amount of sub-trim, I want to check during the setup of the helicopter, and we'll do this as we do the bench setup. After we set the sub-trim, after we set the collective throw to 60%, after we set the cyclic throw to 60%, we'll go ahead and go to the limit with all of that throw and make sure that the servos still move at that point. If the servos still move, we can add a little bit more collective throw if we want to, up until the point where the servo stops moving. I'll show you a little bit of CCPM in the DX6 as we go through the numbers in the DX6, and again, we'll hit it again in the bench setup of the helicopter itself. Here is the CCPM function in the DX6. This is the heart of this radio for any CCPM helicopter. If you don't understand how this works, you will have no chance at setting up the helicopter. On the other hand, if you understand this, setting up a helicopter is really, really easy. The big difference here is that this really adjusts travel adjust and servo reverse. In a helicopter that has a single collective servo that's just mechanical CCPM, travel adjust is in one menu and servo reverse is in the other menu. Everything is together here. This is how it works. First of all, I can turn it on or off. It's on for the features that I showed earlier in the other functions. Then I have the aileron CCPM, elevator CCPM, and collective pitch, or all three servos in the CCPM mode. Then it goes back to the on position. First, for aileron, everything is defaulted to plus 60 for aileron, elevator, and pitch. If I put in a right aileron deflection, this one goes up and this one goes down. If I want to reverse the direction of the aileron throw, I simply beep this to minus 60. And there, my aileron throw is reversed. Now, if I want to reduce the aileron throw a little bit, let me just reset that to plus 60. Now, if I give a deflection and I want to reduce this aileron throw, if I go down, say, to 40, now I've got reduced aileron throw. And exactly the same thing happens for elevator. Minus 60 to reverse it. Drop the numbers down to decrease travel, increase the numbers to increase travel. And the same thing for collective pitch. Go to minus 60 to reverse the collective travel, and then you can go slightly above or slightly below to fine-tune the amount of servo travel that you need for collective pitch. And that finishes up the DX6 function menu. Here's the swash mix, or the eCCPM adjustments for the DX7. They work exactly as I described in the DX6, functioning as travel adjust as well as servo reverse for cyclic pitch and collective pitch. Make sure the exponential is inhibited. If you have these values adjusted to something other than 60%, when you turn on the exponential, it'll essentially kick those values back to 60%, even though it won't reset the numbers. The same thing happens for sub-trim, so make sure that the exponential is inhibited. Now I'm going to cover some items that are not in the DX6, but are in the DX7, the first of which is the auto dual rate and expo page. I've got these inhibited, but if I activate the normal flight mode, I can select position 0 or position 1 or inhibited, and I can do the same thing for stunt mode 1, stunt mode 2, and throttle hold. Now, because I'm running 30% expo in all of these items, I don't use this page, but it is nice to have, and you can use it if you want to. For the timer on the DX7, we have two options. To activate the timer, hit the select button. We have a stopwatch timer which counts up, and you can stop and start that at will. And also we have a countdown timer. It's defaulted to 10 minutes. What I would suggest is that you run it down and start with a conservative number, say 8 minutes, and this would depend on your helicopter and motor and battery pack. Start at a conservative time, and then as you see your helicopter flies longer than 8 minutes, go ahead and increase this time so that the timer sounds when your battery pack has reached minimum voltage. Once you've set the countdown timer, you can go back to the main screen, and it's displayed right here. You can start the countdown by hitting the right rocker switch. You can also stop, and then to reset, just hit the clear button. And that completes the timer options. And finally, here's the servo monitor. Again, the more I use the servo monitor, the more I love it. It's absolutely fantastic because it easily lets me see the program mixes that I set into the transmitter. Now if I scroll forward, here I've come full circle. We're back to the dual rate and expo menu. And so that finishes up all of the function items in the DX7. Now that you've got a handle on all the theory, let's go ahead and set up the T-Rex 450 helicopter using the DX7 radio.